Welcome to The Explainer. Today, we're going to pull back the curtain on the powerful and often invisible force that runs our modern world, information systems. I mean, from your morning coffee order to the global financial markets, they are literally everywhere. You ever stop and think, how on earth does that package I ordered online find its way from some random warehouse to my front door in like a single day? Or how does my bank know my exact balance the split second I swipe my card? Well, the answer to all of that, it lies in these incredibly powerful systems. All right, so what is an information system, really? At its core, it's just an integrated set of components that are all designed to do four things: collect, process, store, and distribute information. The absolute best way to think about it is like the central nervous system of a company. It senses what's happening, makes sense of it all, and then tells the body what to do next. Okay, so let's dive into how this nervous system actually works. It's surprisingly simple, really, when you break it down. It all boils down to this powerful three-step flow. This cycle is the heart of everything. First, you've got input. This is where the system gathers raw data from the world. So think of a cashier scanning a barcode at the grocery store. That beep, that's input. Next up is processing. The system takes that raw scan and turns it into something useful, like, say, updating the store's inventory records. And finally, you get the output. That processed information gets delivered to someone who needs it, like a manager who gets a report showing what's selling fast. It's just this constant, looping flow of data turning into actual insight. So what's actually under the hood? What are these systems made of? It's not just computers and code, you know. It really comes down to 5 essential building blocks that have to work together perfectly. First up, you've got the hardware. This is all the physical stuff you could actually touch. The computers, the giant servers humming away in a data center, the smartphone in your hand. It's the skeleton, the actual physical foundation for the entire operation. And what tells those bones what to do? That's the software. These are all the programs and applications that give the hardware its instructions. So, if the hardware is the skeleton, the software is absolutely the brain, running everything from the operating system to the apps you tap on every single day. Okay, so you've got a brain and a skeleton, but they're not much good without something to act on, right? That's where data comes in. It is the lifeblood of the whole system. We're talking about customer records, purchase transactions, inventory levels, all the raw facts and figures that get pumped through the system to be turned into something valuable. But with all this stuff happening, how do you keep it from turning into total chaos? Well, that's the job of the process. These are the rules, the policies, the step-by-step instructions that make sure everything runs the way it's supposed to. You can think of it like the system's DNA. It's the code that ensures everything happens correctly and consistently, every single time. And finally, we have what is, without a doubt, the most critical component of all. Because without it, the rest is just an expensive pile of metal and code. And that is people. This means everyone, from the IT pros who build and maintain the system to the everyday folks like you and me who use it. A system has absolutely no purpose without people. So we know what it's made of. But how do you go from just an idea scribbled on a napkin to a massive global system? Well, it's not random. There's a structured blueprint for this, and it's called the information system lifecycle. This whole journey kicks off with a feasibility study. That's basically just asking, hey, is this even a good idea? Can we do it? Should we do it? If the answer is yes, you move on to system analysis, where you figure out exactly what the system needs to do. Then comes system design, which is like drawing up the detailed architectural blueprints. After that, it's time to roll up your sleeves and actually build the thing. That's programming and testing. Once it's built and ready, it's time for installation, which is just the fancy way of saying going live. But it doesn't stop there. The final and longest phase is operation and maintenance, which is all about keeping the system running smoothly, day in and day out. Okay, so it's pretty clear that not all systems are created equal, right? They're not one size fits all. They're highly specialized tools, and different types power every single part of a modern organization. Let's look at 3 big ones. First, you've got the workhorse, the transaction processing system, or TPS. These systems handle the thousands of routine, daily transactions, like an ATM withdrawal or an online checkout. Then you have customer relationship management, or CRM systems. This is all about managing every interaction with a customer. Think of a sales team using Salesforce to track their leads. And then there's the big one, the whole shebang, the Enterprise Resource Planning System, or ERP. This is a massive system that integrates all the core parts of a business, like one single program that manages a company's entire global supply chain.
But here's the thing, no matter how sophisticated or expensive the system is, it all comes down to one simple, brutal rule. Garbage in, garbage out. A system is only as good as the data you feed it, and that brings us to two really important problems we have to understand: bias and error.
Now, it's super important to get the difference here. A data error is a random mistake, a simple typo in a zip code, for instance. It's a one-off problem. But data bias, oh, that's a whole different beast. It's a systematic problem that consistently pushes the data in one direction, which skews all of the results. Imagine a survey about a new park, but you only survey people who live right next to it. The results are going to be biased, right? Understanding this difference is absolutely critical if we want to trust the information these systems give us. So, this brings us to one last really critical thought. We've seen how these systems act as the invisible nervous system for, well, basically everything. Our global economy, our governments, our daily lives. So, I'll just leave you with this question to think about. If our entire world runs on this information, what happens when the information is wrong?